Hello and welcome to our discussion on thunderstorms. In this video, we're going to talk about thunderstorm avoidance. And specifically, we're going to look at the rules of thumb for thunderstorm avoidance, as well as how to handle the aircraft in the case that you inadvertently encounter a thunderstorm. So these rules of thumb come from the Aeronautical Information Manual. Also, there is an advisory circular out from the FAA on thunderstorms that list these rules of thumb. Also, there are one or two rules of thumb in here from different airline training facilities. So the first rule of thumb, of course, is don't take off or land in the face of an approaching thunderstorm. And the reason for that, of course, is that thunderstorms can put out strong winds well ahead of them, and that will result in wind shear. So you need to estimate the distance of the thunderstorm, the life of the thunderstorm, and the strength of the thunderstorm, and then figure out from that what is a safe distance. Sometimes that may be 5 miles, sometimes that may be 1 mile, sometimes that may be 10 miles. So it depends upon all these factors. You have to assess the thunderstorm, determine what type of thunderstorm it is. Another rule of thumb is to don't attempt to fly under a thunderstorm even if you can see through to the other side. And the reason for that is because the precipitation shaft, of course, may contain hail. Also, you know that where there's precipitation, more than likely there is also a strong downdraft. So if you're flying close to the ground with an airplane with marginal performance, that may push the airplane into the ground. So also, there is, of course, lightning and other hazards associated with thunderstorms. So it's not a good idea to fly through a thunderstorm even though you can see through the other side.
It is inadvisable to fly underneath the anvil of a thunderstorm for several reasons. One reason is that the anvil is a charged part of a thunderstorm. Typically, it has a net positive charge, and as a result, flying near or through the anvil will result in a lightning strike. Another reason is because as precipitation falls into the anvil, in other words, it gets blown out of the thunderstorm and precipitation-sized particles fall through the anvil, they start to evaporate, and they produce something called mimmatus. And mimmatus clouds by themselves are very pretty, but they also have strong downdrafts. As precipitation falls, it evaporates, cools the air, which induces a downdraft. So you may find turbulence in the anvil or the regions of the anvil. And the third reason you don't want to fly near or in the anvil is because with very vigorous thunderstorms, the hailstones may get thrown out of the updraft and into the surrounding anvil closer to the storm. And as a result, they may fall out of the anvil and damage the aircraft.
Another rule of thumb is don't fly without airborne weather radar into a cloud mass containing scattered embedded thunderstorms. If you're trying to fly a cluster of thunderstorms, especially IFR, where you cannot see ahead, then you've got some problems. If you're flying an airplane that does not have radar, then you're left to visual means to circumnavigate the thunderstorms. However, airborne weather radar is very good. Airborne weather radar will allow you to find routes where there are not strong thunderstorms and to avoid the strongest cells. Another thing that these days technology has improved, and we have ATSC or FISB in the cockpit. FISB is Flight Information Service broadcast provided by the FAA free. It allows you to uplink into your aircraft NEXRAD radar from the National Weather Service network. Now the problem with that, though, is that there is a latency issue, and sometimes, of course, it may take up to 20 to 30 minutes to get a current radar image. Remember that radar volumes typically take anywhere from 6 to 10 minutes to complete. In other words, the radar scans the sky, and then after that time period, it's sent to a computer where it's processed and then sent to your aircraft. So trying to fly around thunderstorms. Thunderstorms, remember, develop very quickly. Their life scale or lifetime is typically for a cell is about 30 minutes for some thunderstorms. Some may last longer, but you want to make sure that you have the most current information. Flying around a thunderstorm with just FISB sometimes can be difficult because of the update rate of the radar image. So remember, we said that in the FISB section, the flight information section, that you should use FISB for strategic planning and not tactical. Strategic means looking ahead of the aircraft and trying to determine a route around thunderstorms, an area of thunderstorms, rather than trying to circumnavigate individual cells. Another rule of thumb for thunderstorm flying is don't trust the visual appearance to be a reliable indicator of the turbulence inside a thunderstorm. Of course, all thunderstorms and growing towering cumulus clouds do have updrafts and downdrafts in the mature stage. Towering cumulus, of course, it's all updraft, and you'll get quite a ride flying through a thunderstorm as you encounter these updrafts and downdrafts. So even though the thunderstorm has iced out and it looks like it's in dissipating stages, you may still have strong downdrafts, and you definitely want to avoid those storms.
You should not assume that air traffic control will offer radar navigation guidance or deviations around thunderstorms. When the weather gets rough and there are lots of thunderstorms, air traffic control gets very busy handling deviations. And they may not necessarily be watching you very closely. If you need to deviate, especially if you're on an IFR flight plan, you should contact air traffic control and tell them what direction, how many degrees, and how many miles you expect to deviate in that direction. Remember that you shouldn't use NEXRAD mosaic imagery from FISB or data link weather into the cockpit as your only means for negotiating a path through an area of thunderstorms. In other words, tactical maneuvering. The only way or the only time you should use radar in navigating through thunderstorms is with airborne weather radar. If you have airborne weather radar, then you're getting an update on the weather picture every 30 seconds or less, every time the radar sweeps. Whereas, remember, NEXRAD imagery, there is some latency issues. And speaking of FISB or NEXRAD information or data link into the cockpit, latency, typically when you're looking at a radar image that was provided from ground transmitters into the cockpit, you may have up to 20 or 30 minutes of delay. In other words, the picture that you're seeing on your device is not necessarily what's happening outside the window. So there's a problem, and that's why data link weather should only be used strategically and not tactically to fly around thunderstorms. It's really helpful to listen to air traffic control, the frequency, and listen to all the pilots that are deviating around thunderstorms. It gives you an idea of where the worst activity is and where there seems to be less activity. So it gives you good situational awareness to figure out where you want to send your airplane, where you want to take your airplane. It's also helpful to ask air traffic control for deviations around thunderstorms and also for suggestions where to go and how to fly around an area of storms. Data link weather radar imagery should be used in the cockpit really for strategic planning purposes. In other words, to avoid entire areas of thunderstorm. Once again, there's a latency issue, and it's best to use the radar imagery that you have early to figure out your plan of action. If you are deviating around an area of thunderstorms as a result of an air traffic control clearance, it's best when you switch frequencies to a new controller to tell them that you're deviating around those thunderstorms before you accept a clearance to rejoin your route. That way gives the controller a heads up that you have weather ahead of you and that you do need a little bit of help. Also, if you are deviating around thunderstorms, it's best to make sure that your route is clear before you rejoin your route. In other words, there could be some thunderstorms along your route, and you may need to continue to deviate around those storms before you rejoin your original route.
Another rule of thumb is to avoid thunderstorms by 20 miles, ones that are identified as severe or giving an intense radar echo. Now remember, severe means that it has either a tornado or large hail or strong winds more than 50 miles an hour at the surface. So a severe thunderstorm should definitely be avoided. Give it a lot of distance. And then any thunderstorm that has an intense radar echo. So in other words, if you're looking at airborne weather radar, and for that matter, FSB, if it's showing red, then that is a storm that needs to be avoided by at least 20 miles.
Pilots should circumnavigate the entire area of thunderstorms if more than half that area has thunderstorm coverage. In other words, if there is a squall line or just a large area of thunderstorms, it cannot be safely navigated by trying to pick your way through the storms. The entire area should be circumnavigated. In this image, you can see an aircraft, commercial aircraft flying. Shortest distance would be, of course, a straight line. But when there are thunderstorms, you have to navigate around those storms. Sometimes it'll take you hundreds of miles out of your original direction, but it must be done.
Also remember that vivid and frequent lightning indicates the probability of severe thunderstorms. What that means is typically what happens is when thunderstorms are cycling, their updrafts are surging. They get a resurgence of updrafts if it's a long-lived thunderstorm. And with that, with the increased updraft strength, you'll get the initiation of charge separation again, which causes more lightning. So if you see lots of lightning, typically it means that the thunderstorm is recycling, or in other words, the updraft is surging or pulsing. And usually thunderstorms that have pulsing updrafts are long-lived ones and typically are severe. Do you regard as extremely hazardous any thunderstorm with tops 35,000 feet or higher, whether the top is visually sighted or determined by radar? And typically thunderstorms usually form when, of course, the cloud goes well above the freezing level and you get charge separation. Depending upon the time of year, the freezing level may be high or low. We talked about this earlier. And during the summertime, thunderstorm or freezing levels are typically up anywhere between 12 to 16,000 feet or higher. If you have a lower freezing level, you can get thunderstorms, or in other words, lightning, with low top thunderstorms. Sometimes the tops may only be 25,000 feet or so. But during the summertime, usually with higher freezing levels, that means that you're not going to get lightning until the thunderstorm goes above maybe about 30,000 feet. So the higher, of course, the thunderstorm, the more dangerous it is, the more instability, depending upon, of course, the tropopause. The tropopause is usually the top of the thunderstorm, unless you have overshooting tops. So to just summarize, when storms go up above 35,000 feet, you know you got a strong storm, and that's something that you should avoid. And here's the red tail rule. Do avoid region downwind of a thunderstorm by at least 1 nautical mile for each knot of wind at altitude. So we went through this rule before, an example, very good rule. This rule came about from an accident Northwest Airlines had back in the 1960s. So you should use this rule of thumb when determining how far downwind of a thunderstorm you should fly.
And as a courtesy to other pilots and also to forecasters and air traffic control, if you are experiencing thunderstorms, it's nice to pass on that information in the form of a PIREP. As the saying goes, it's best to be on the ground wishing you were flying than to be in the air wishing you were on the ground. So when you are flying around thunderstorms and you see no possible way around the area of thunderstorms, sometimes it's best just to land and sit it out.
So those are the rules for avoidance. If you do inadvertently encounter a thunderstorm, then you're at the wrong place at the wrong time, and there's some things you need to do.
Before you enter a thunderstorm, you should lower your seat and also make sure your safety belt is tight and your shoulder harness is tight also. And the reason for that is because thunderstorms are very turbulent. You'll be tossed, and each successive toss or updraft will loosen your seatbelt to the point where you may eventually bounce off the ceiling. So you want to make sure that you have plenty of space between the ceiling and your head. And also you want to make sure that, of course, your safety belt is tight. Also, if you have a hat, if you're wearing a baseball hat, those little metal knobs on the top really hurt when you hit the ceiling. Likewise with the headset. So, of course, you want to talk to people with a headset, but you may not necessarily need to wear that hat. And then also, it's advantageous to continue flying straight through the thunderstorm in the minimum amount of time. That means that you don't want to make any turns as you fly through the thunderstorm. Also, you want to make sure that your aircraft is at an altitude well below or well above 0 to minus 15 degrees Celsius. Remember, that's where you get the most clear ice. So you want to avoid the region where there is lots of super cool liquid water. And you also want to make sure that your pitot heat is on. Turn on the carb heat or your engine anti-ice. And then also slow the aircraft down. So bring the power back a little bit so that you slow down below turbulence penetration airspeed. You want to also turn the cockpit lights up to their brightest illumination because lightning strikes, of course, are very bright, and your eyes will become adjusted to the brightness if you have the lights up already. Also, you want to make sure that the autopilot is disengaged. You'll be hand flying the airplane, and that means you're going to be flying for attitude and not necessarily to maintain a particular airspeed or a particular altitude. And then if you have weather radar, you want to tilt it up and down to get a vertical picture of what's going on in the storm to see if there's any stronger radar returns above you or down below you. Finally, when you enter a thunderstorm, you want to maintain attitude and not altitude or airspeed. So you want to make sure that the wings are level and the airplane stays right side up at all times. Don't really want to change power or thrust settings very much. If you do have to turn, the turns should be very shallow. And once you get into a thunderstorm, don't turn around. Thunderstorms are typically only about 5 to 7 miles across at their widest, unless, of course, you're flying through a supercell, and then that's another problem. But if you're flying through an ordinary thunderstorm, typically it's a short period of time through it. You go in, you go up, you come down, you come out the other side, and hopefully the wings are still on the airplane.
So I hope that was helpful. That's what you should do when you're flying around thunderstorms.